Today, I will be explaining the difference between asset interest and ordinary interest. Asset interest is calculated using the actual number of days in the loan period and a 365-day year or 366 in a leap year. This method is more accurate because it follows the real calendar. Ordinary interest assumes a 36-day year because the year is shortened, the interest per day is slightly higher, so which gives the lender more money. Ordinary interest because dividing by 360 makes each other interest large.
Now, let's look at question number 2. A client invests 10,000 ringgit on 10 January 2024 and withdraws it on 30 March 2024. We need to calculate the exact number of days for this investment. To this correctly, we follow two rules. First, we exclude the starting day, which is 10 January. Second, we include the ending day, which is 30 March. Now, let's count the day month by month. For January 2024, we begin counting from 12 January to 31 January. That gives us 21 days. Next, February 2024. Since 2024 is a leap year, February has 29 days. So we count the entire month. That gives us 29 days. Then we move to March 2024. We count from 1 March to 30 March, which is 30 days. Now we add up the days. 21 days from January plus 29 days from February plus 30 days from March. So the exact investment period is 80 days.
I will be explaining the last question about why the simple interest rate is 6% per annum. The question states that a loan of 5,000 ringgit earns 150 ringgit in interest over 6 months. We use the simple interest formula, which is interest equals principal times rate times time. From the question, the interest is 150 ringgit, the principal is 5,000 ringgit, and the time of 6 months is equal to half a year. To find interest rate, we rearrange the formula so that rate equals interest divided by principal times time. Substituting the values, we divide 150 by 5,000 multiplied by half a year. This gives 0.06, which is equal to 6%. Therefore, the simple rate charged is 6% per annum.
Hello everyone, today I will explain compound interest and how to calculate future value and the effective annual rate or EAR using simple examples. Question 1. Calculating future value with compound interest. For the first question, we are given several important pieces of information. First, the principal amount invested is 2,500 ringgit. Second, the annual interest rate is 8%, which is 0.08 in the decimal form. Third, the investment period is 3 years. The interest is compound quarterly, meaning 4 times a year. The first step is to find the periodic interest rate. Since the interest is compounded for 4 times a year, we divide 8% by 4. So the interest rate per quarter is 2% or 0.02. Next, we calculate the number of periods. 3 years multiplied by 4 periods per year gives us 12 periods. Now we substitute these values into the compound interest formula. Future value equals P times open bracket 1 plus I close bracket to the power of n. Future value equals 2,500 ringgit multiplied by 1.02 to the power of 12. After calculating, the future value is approximately 3,170 ringgit and 60 cents. In conclusion, 2,500 ringgit invested at 8% per year and compounded quarterly will grow to 3,170 ringgit and 60 cents after 3 years. For the question number 2, understanding the effective annual rate EAR. Now let's move on to the second question. In this question, we compare two investments that both offer a 10% nominal interest rate per year. The difference lies in the compounding frequency. One investment is compounded annually, which means interest is added once a year. The other investment is compounded monthly, which means interest is added 12 times a year. Although the stated interest rate is the same, the actual return is different. This is why we use the effective annual rate or EAR. EAR represents the true annual interest rate after considering the effect of compounding. To calculate the EAR for monthly compounding, we use the formula EAR equals open bracket 1 plus R divided by M close bracket to the power of M minus 1. Here, R is 0.1, which represents 10%, and M is 12 months. After calculating, the EAR is approximately 10.47%. This means that even though both investments take a 10% interest rate, the investment compounded monthly provides a higher effective annual return. In conclusion, the more frequently interest is compounded, the higher the actual return earned.
Okay everyone, let's look at question 3. In this question, the client wants to have earned 20,000 after 5 years. The bank offers an interest rate of 6% per year, compounded semi-annually. Our task is to find out how much money the client must deposit today. First, let's identify the information given. The future value is Rm20,000. The interest rate is 6% per annum. The time period is 5 years and the interest is compounded semi-annually, meaning twice a year. Now, we convert the interest rate and time into semi-annual terms. 6% divided by 2 gives 3% or 0.03. 5 years times 2 equals 10 periods. Now, we use the present value formula. Present value equals future value divided by open bracket 1 plus r close bracket to the power of n. We substitute the values. Present value equals 20,000 divided by open bracket 1.03 close bracket to the power of 10. Now we calculate the power. 1.03 to the power of 10 is approximately 1.3439. Finally, we calculate the present value. 20,000 divided by 1.3439 equals approximately 14,880 ringgit and 40 cents. Therefore, the client must deposit approximately 14,800 ringgit and 40 cents today to obtain 20,000 ringgit in 5 years at 6% compounded semi-annual.
A client saves Rm200 every month for 2 years in an account that pays 3% annual interest compounded monthly. Since the money is being deposited regularly, to find the future total, this situation uses the future value of annuity formula. For the formula is FV equal R times open bracket 1 plus I close bracket power n minus 1 all over I, where R equals 200, I equals 0.03 divided by 12 equals 0.0025, and n equals 24 months. Substituting into the formula, FV equals 200 times open bracket 1.0025 close bracket power 24 minus 1 all over divide by 0.0025. We got FV 200 times 24.72, and the final answer is FV equals Rm 4,944. For the conclusion is saving Rm200 every month for 2 years result in approximately we got Rm 4,944. Next, question 2. Loan monthly payment. A business borrow Rm 5,000 and repay it over 6 months at 12% interest compounded monthly. This use the present value of annuity formula. So, for the formula is R equal PV times I all over 1 minus open bracket 1 plus I close bracket power negative n, where we got PV equals 5,000, I equals 0.01, and n equals 6. We put it into formula. R equals 5,000 times 0.01 all over 1 minus open bracket 1.01 close bracket power negative 6, and we got R equals 50 divided by 0.058. The answer is Rm 862.07. For the conclusion is the monthly installment is Rm 862.07. Finally, question 3. First month interest and principal. We calculate how much of the first payment goes to interest and how much goes to principal. Interest 5,000 times 0.01 equals Rm 50. Principal paid 862.07 minus 50 equals Rm 812.07. So we got interest equals Rm 50, principal equals Rm 812.07. Overall conclusions, this question show how annuity formula helped us plan saving and understand loan repayments, including how interest affects what we actually pay. That's all from me. Thank you.